What is the tragedy of the commons? The tragedy of the commons is a situation where a resource that is rival, your use subtracts from mine, and hard to exclude people from using, gets overused and degraded because each individual has a private incentive to take a bit more, while the costs are spread across all users. Classic examples include open access fisheries, common grazing lands, groundwater aquifers, and the capacity of the atmosphere to absorb CO2. Here's the intuition. When I harvest one more fish from an unmanaged stock, I get the full benefit of that fish. But the depletion cost, slightly fewer fish left to reproduce, slightly lower catch for everyone else, is diluted across the whole group and the future. Because I don't fully internalize that cost, I extract more than is socially efficient. Scale that logic across many users and you get overuse, congestion, and in extreme cases, collapse. A bit of history. The idea predates its famous label. In 1954, H. Scott Gordon formalized how open access fisheries dissipate economic rents. Competition drives effort up until average revenue equals average cost, leaving zero profit and a depleted stock. In 1968, biologist Garrett Hardin popularized the concept with his famous essay, The Tragedy of the Commons, describing villagers overgrazing a shared pasture. Hardin's storytelling was memorable, but he blurred an important distinction: open access, no rules at all, versus common property, a shared resource governed by rules. That distinction is central to Elinor Ostrom's work, Nobel Prize, 2009, which documented how communities around the world successfully govern common pool resources using locally crafted rules, monitoring and sanctions, avoiding tragedy without privatization or heavy-handed central control. The simplest economic model shows why tragedy arises. Each user chooses effort to maximize private net benefits, ignoring the marginal external cost imposed on others. The non-cooperative Nash equilibrium features too much effort and too little stock relative to the social optimum, where a planner would set total effort so that marginal social benefit equals marginal social cost. In renewable systems, fish, forests, aquifers, dynamics matter. The efficient path keeps the stock near a regenerative sweet spot, whereas open access often pushes stocks below that level, sometimes into collapse if growth can't keep up with extraction. Real-world illustrations make it concrete. Fisheries without limits exhibit a race to fish, short seasons, bigger gear, and wasteful bycatch. Groundwater pumping in unregulated basins lowers the water table, raising everyone's costs and risking saltwater intrusion. Urban roads at rush hour behave like a commons. Each extra car slows others. Congestion, a classic negative externality. Climate is a planetary scale commons problem. Each emitter enjoys the benefits of energy use while the warming costs are diffused globally. What prevents tragedy? 3 families of solutions align private incentives with the collective interest. Rules and regulation. Quotas, seasons, gear limits, protected areas, backed by monitoring and enforcement. Property or use rights, e.g., individual transferable quotas in fisheries, tradable groundwater rights, which make the future value of the stock part of each user's calculus. Community governance following Ostrom's design principles. Clear boundaries, rules adapted to local conditions, user participation in rulemaking, accountable monitors, graduated sanctions, cheap conflict resolution, and nested institutions for larger systems. 2 curiosities. First, not all commons are tragic. Knowledge, open-source software, or digital goods are often non-rival, so more users don't diminish supply, sometimes producing a comedy of the commons. Second, technology can move resources between categories. Satellite tracking and electronic monitoring make exclusion cheaper, enabling tradable rights where it was once impractical. Bottom line, the tragedy of the commons is not fate. With well-designed institutions, public, private, or community-based, we can turn a destructive race into sustainable stewardship. Up above, I've left you more videos so you can keep learning law. Remember to give us a like and subscribe.